Thank you. Well, thanks for that great introduction, and it's a pleasure being here, part of this team. I think we really are at a very, very interesting time in the networking industry, right? We are in the middle of, I guess, multiple technology inflection points, and so today we'll talk a little bit about what perhaps the future of networking could look like when you take some of these inflection points coming together. I think the previous session was actually very good because it talked about some broader trends. It talked about computing, mobile devices, networking. And so I'll take the networking piece and perhaps dive a little more into that and see if we can open up a window into what that may look like. In order to do that, it's also important to understand what are some of the trends that are driving the future, right? And there are some very interesting trends coming about. Now, the first one is convergence to Ethernet. Now, we all know Ethernet is no longer just a LAN technology. But if you look at where Ethernet is going today, right, or if you look at the world of non-Ethernet versus the world of Ethernet, the world of non-Ethernet is much, much larger, right? And Ethernet is now beginning to get into traditional areas where it never had a presence. So, for example, there's work going on in the IEEE around AVB. How many of you are familiar with AVB, audio video bridging? Just one person, good. Think about Super Bowl, right? And you've got 30 video cameras all on the ground covering the event from all angles. And every one of those cameras has an HD stream, it has an audio stream, it has a return video stream so that the camera vendor can actually see what's being shown on the TVs. And it has timing, right? And that's the most important piece, because what happens is as they cut from one video feed, from one camera feed to another, on the TVs, everything has to be synchronized so you don't see a phase delay, right? The screens don't overlap or shift. And so timing is very critical in those environments. Now, all of this today runs by and large on either proprietary technology, analog transmissions. There is no Ethernet there, right? There's proprietary cabling infrastructure or technologies for that industry. What's happening is all of that is now beginning to start converging on Ethernet, right? So ABB technology provides the ability to provide timing over Ethernet, synchronization, bandwidth reservation, and resource guarantees. And there's a whole ecosystem of vendors coming together to start building equipment that can start leveraging Ethernet, a single Ethernet cable from that camera to carry high definition audio, to carry video for the return streams, for timing, synchronization, all of that stuff, right? So Ethernet's now getting into these areas where it never had a presence. On the more traditional side, on the networking side, we're seeing Ethernet get into areas where you've had other networking technologies, but time synchronous technologies like T1, E1 interfaces, right? So as you think about the mobile backhaul infrastructure refresh, which is beginning to happen from 2G, 3G to 4G LTE, the backhaul from the cell towers is all moving from T1, T3 interfaces to Ethernet. And there again, there are technologies like PTP, Precision Time Protocol, 1588, that allow that transition to happen. So that's another area where Ethernet is getting into. A third area, this one's very interesting, right? Electrical systems. As we start moving into energy efficient lighting, and people are talking about LED-based lighting systems which consume less power, right, are much more energy efficient. People are beginning to talk about actually running lighting systems on Ethernet and using power over Ethernet. People are familiar with PoE? Most of you, right? And PoE started with like 15.4 watts, then it's moved up to PoE plus, 25, 30 watts, and then down the road people are talking about 55, 60 watts, all over an Ethernet cable, right? And now you're talking about actually powering up LED systems, and not just one or two lights, right? This is commercial lighting systems based on Ethernet, all getting powered from a centralized controller, which is another very interesting area. And then you have, lots and lots of other areas, surveillance cameras, right, which are running analog, coax. Those are all beginning to move over Ethernet as well. So this is all good, but what's the relevance to what we are discussing here, right? What's actually happening is that networking is now going to start moving into traditional non-networking domains, and it will provide a common transport, right, a common underlying infrastructure, which for developers will start providing common programmatic interfaces that you can start taking advantage of in areas where networking has never been, right? And in fact, it's going to start driving the world from a world of connected devices, lights are connected to switches, right, to a world of network devices. And that's a fundamental shift that's beginning to happen, right? So that's one big trend. The other one, of course, is, we talk about software-defined networking, right? And everybody talks about SDN from the perspective of centralized controller, centralized control management plane, open flow, programmability. But I think there's a much larger trend that's under the SDN umbrella that doesn't get talked about as often, right? And I think this one is truly transformative, right? It can completely change the networking industry. And it's still under the SDN paradigm, but it doesn't just get talked about often enough. And that is the phenomenon of disaggregation, right? We saw this happen in the computing industry, right? Everybody knows mainframe, vertically integrated system, proprietary silicon, chipsets, specialized operating systems, specialized applications. And in order to gain new applications, the customers would have to go to the vendor who's building that vertically integrated system and say, hey, I need an application for word processing, or I need an application for spreadsheets, or whatever, right? And everything came from the same vendor. Now what happened is over time, that specialized silicon eventually moved to merchant silicon, for example, the x86, right, which Intel brought to the market. And that opened up a set of programmatic interfaces for the underlying hardware, right? Once that happened, people could start building operating systems on top of that, right, and all the tool chains and toolkits that come with that. And then the operating systems opened up a set of APIs that allowed application developers to go build applications. And the whole computing industry got transformed. I think we're at the very early stages of an exactly similar transition in the networking industry, right? And it's a multi-year transition. It's a decade-long, perhaps multi-decade-long transition, but that's happening. Today, what we find, in many cases, routers, switches are still vertically integrated, right? So the silicon is proprietary silicon. The ASICs are proprietary ASICs that switching vendors build. They have a specialized control plane, and they have a specialized set of applications or protocol stacks. And if a vendor wants some new features or new capabilities, he has to go to that same vendor who's building that switch or router and wait until the vendor can give him those capabilities. If you look at where this transition is going, that proprietary silicon is now slowly transitioning to merchant silicon. If you look at the direction that merchant silicon vendors are going, companies like Broadcom, Intel, Marvell, they are building merchant silicon for networking, which is extremely powerful, equivalent or perhaps even more powerful than the proprietary silicon that went into these switches or routers. And what's more important is that that merchant silicon is now exposing open APIs, instruction sets to be able to program on top of that, right? So that transition is beginning to happen. And along with that, my view is, as you look out 5 years, 10 years from now, what you will have is you'll have a set of family of silicon vendors, whether it's Intel, Broadcom, Marvell, that will build that silicon, right? And then you'll have a set of vendors who will build control planes on top of that, right? And they need not be the same vendor. They'll be disjointed, they'll be disaggregated. And that control plane itself will have a set of APIs on top for networking that will allow people to go build applications on top of those control planes, right? And each of these layers will be completely disaggregated from each other. You can go to any one vendor to get the applications for that space or the operating system that you want or the underlying hardware as well. And you can go to different vendors for all of these. So what does all of this mean to us? It means that the move towards software-defined networking is really going to provide the opportunity as you extrapolate out to program at every layer of the stack, right? You will have the ability, there'll be people who specialize in building the silicon, and they will provide programmable silicon. They will provide silicon that has programmable tool sets, tool chains, board support packages. All of that will be available, and you'll go off and be able to build a set of operating systems, on top of that. Right? And there'll be a limited set of vendors who will build these operating systems, right? Not everybody will do it, but there'll be a set of vendors who will go specialize in doing that. And they will build the operating systems, the control planes, and along with that, the toolkits to go build applications on top of that. Now, because we're talking about networking, we're not talking about devices, we're talking about the whole network, there will also be a set of vendors that will go build centralized platforms to sit on top of these switches or these operating systems, right? You're beginning to see that happen today with OpenFlow. There are vendors who are specializing in OpenFlow controllers. But as you look out into the other areas where Ethernet is going, we talked about energy efficient lighting, audio video bridging. It is conceivable that you will have a set of vendors building control planes and management platforms for those specific verticals, right? I mean, if you're talking about energy efficient lighting, you may have a completely different centralized control plane that deals with lighting, that deals with things like luminosity, that deals with things like motion control, right? And you may not have all the other things you want from a data center controller, so to speak. So I think down the road, you will actually have an industry that will spawn off a bunch of controller vendors for these different segments that networking is now beginning to get into. Another example is if you think about video surveillance systems, camera surveillance systems. Today, all of them have a VMS, right? A video management system or a video management server. As networking moves into that arena, you can imagine that the controller will now incorporate elements of networking into it, right? How do I turn on and off that camera using PoE? How do I monitor the status of how much data is coming from that camera? Is the camera operational? Is it not operational? And all of that will get tied into the VMS as well, right? So you'll have a separate controller for that particular application. And obviously on top of that, you'll have applications for every need. Right? You'll have applications that deal with the data center in terms of things like data center infrastructure management, data center optimization. You'll have applications that deal with things like BYOD, identity management, role-based access control. You'll have applications that deal with smart lighting systems. You'll have applications that deal with broadcast management systems. And you will have, in my view, I actually floated this idea at the last ONS, the need for an app store for networking, that you can actually start putting these applications on. But I thought about that a little more, and in my view, actually what will land up happening many years down the road is you will have multiple app stores, right? You'll have an app store for the, the video surveillance industry. You'll have an app store for folks doing HD video broadcast. You'll have an app store for folks who are involved in data center optimization, right? And they will all work on their controller systems. So there'll be a variety of app stores where you'll go to for applications for your specific industry, which, by the way, to all of us is actually very good, because it allows all of us to let our creative juices flow in all these different areas and really think about what kind of applications can be enabled. Right, so I think this is, again, it's a multi-year transition. It's not something that's going to happen overnight, but I do think it's a transition that's happening, so to speak. Now, there's been a lot of talk about SDN and OpenFlow and the commoditization of networking hardware. In my view, actually, this transition to SDN actually provides an opportunity for differentiation, right, not commoditization. And the example one can draw over here is that even though you can have a Windows laptop, right, and you can have a MacBook, right, the underlying hardware, the CPU can be the same, but the user experience is completely different, right? It all depends on how you build the OSs. It all depends on how you build the applications that sit on top of that, right? So I think there's a tremendous opportunity to really break the industry apart and provide very, very differentiated solutions that go address specific needs, specific requirements, and customization based on what the end user is ultimately looking for. So I think it's a very positive trend. Now, this is the key part, right? What's in it for the customer? What's in it for the guy who's running the network? What's in it for the IT administrator, right? This is great for us. I mean, we think about all of this and get excited. But at the end, does it really do anything for the end user? And I think there's some very positive aspects that will come out of this. The first one is it'll break the vendor dependency cycle. And what that means is today, as an IT administrator, as a CIO, if I have to invest in my network infrastructure, and my network's evolving, right? I got to deal with BYOD challenges on the campus side. I got to deal with virtualization challenges on the data center side. I need new features. I need new capabilities quickly to evolve to my network requirements. Today, that cannot be done, because what happens is the IT administrator will come to the network vendor and say, I need these sets of capabilities. And for the vendors, we see these requests globally from all our customers. And it goes into a prioritization exercise, and some features get done soon. Some get done in 12 months, some get done in 24 months. And the customer has no recourse, right? I mean, they got to wait. When you move towards this kind of a model of disaggregation, right, the user, the end user, the IT administrator can now go leverage an independent software community, all of us, right, to go build applications much more quickly than they would have otherwise had available to them. Right? So they can adapt the network, they can evolve the network very quickly by leveraging this broad developer community to go address the problems in near real time, so to speak. The other big thing I think it brings to the customer is it allows them to deploy targeted solutions. Again, today when you think about how a network administrator runs his network, if a vendor provides the network administrator saying, hey, your switches need to be upgraded to XYZ release, that release has a bunch of things into it, right? It may have updates for the protocol stacks, it may have bug fixes for other areas, it may have some new modules in there, but maybe what the customer is looking for is a targeted patch or just one feature. His OSPF is working just fine, he doesn't want to touch that, but he doesn't have a choice, he's got to go upgrade to the new release, right? And so the challenge today for the end user is that whenever they have to upgrade the infrastructure, it is a vendor-driven model, right? It's what the vendor pushes out to them, right? When you look at this kind of disaggregation, it will allow the end customer to actually deploy targeted solutions for what they want, not what the vendor is pushing out to them, which again I think is very positive. The third one is the ability to rapidly evolve solutions, right? If there's a broad community of software developers at every layer of the stack, the IT administrator can go and leverage that community to rapidly deploy solutions and not have to wait for 12, 18 months that he would have normally had to do if it was completely in the hands of the vendor. This last one is also very interesting, right? This notion of discontinuity from the past 2 decades of networking. If you think about networking by and large, it's evolved. You've gone from 10 megabits, 100 meg, gig, 10 gig, 40 gig, 100 gig. But the fundamental paradigms, the fundamental tools you've had haven't changed over the last couple of decades. We're still dealing in terms of MAC addresses. We're still dealing in terms of IP addresses. We're still doing things in terms of VLANs, right? What is needed today is if an IT administrator has to go solve his BYOD problem, he wants to deal in terms of what are the devices on my network? Who are the users on my network? What are the applications on my network, right? And there aren't any tools available to go deal with the network from that perspective. It's all about IP addresses, MAC addresses, VLANs when you get down to actually running the network, right? And this discontinuity in terms of thinking, in terms of tools, in terms of operational models will, I think, come about as SDN starts disaggregating the vertically integrated stack. So I think there's some big changes on the horizon. None of this is going to happen overnight, but I do think the industry direction is moving in the right direction at this point. Now, the key, of course, to all of this is APIs. Right? APIs at every layer, right? But the APIs need to be content-rich, right? I mean, we've used APIs like get time of day when you're programming, right? We need APIs like get user by name, right? If I type in a name, I need to know exactly who the user is, where is he coming from, what port, which device. I need those kind of APIs, content-rich APIs on which I can start building a set of applications, right? And I think until those APIs come to market, we will still be tied down to IP addresses, MAC addresses, and VLANs. Now, the good thing is people are thinking about this, right? They are thinking about how do we make these content-rich APIs available? How do we start, even if it's in a proprietary approach, and then go down the standardization path, right? But the thought process has begun. And I think it's those content-rich APIs which will truly transform the industry and allow us to go build some very interesting and unique applications, right? Now, the question is, what do those look like? So this is where I won't come in and say, this is what the future is, or these are the applications, but we'll take a couple of examples and walk through them just as food for thought. I like this. We think of network security as a way to control access, right? And many people who think about security think about it as, let me tighten the network up. My view is a little bit different, right? I think the role of network security is to make sure that the network is available when there's a threat. I mean, what good is a network if it can't network, right? And so the whole notion of being able to control without compromise is very critical in terms of the whole notion of network security. And for that, you need content-rich APIs that can tell you who's accessing the network. Give me the list of users, the names, and this has to be ingrained into the network. I don't need a separate device, a separate appliance, a separate application. I want to be able to use my network programming capabilities to tell me exactly who are the users on the network. What is their role? Is it an employee? Is it a contractor? Is it a guest? Who's the user? Is it a device? Is it a virtual machine? Is it a printer? Right? I need that kind of richness from my network to be able to really tell who's using the network. What are they doing on the network? Right? Give me applications by user. There should be an API that says, if this is the user, tell me all the applications he's used in the last hour, right? And I should be able to return to you the set of applications. That kind of visibility is truly needed to be able to go build some interesting solutions. Where are they coming from? The notion of locality, the notion of location is very important, right? To some people, if it's an employee who's trusted and he's accessing the network from within the premises of the building, that's one thing. But if the same employee is outside the premises of the building from the parking lot, accessing the same wireless network, perhaps he gets a different set of access privileges. And so I need to know, what is the location of that user? Is he coming from home? Is he coming from the parking lot? Where is he actually coming in from? From what device? I've got 4 devices. Where are all the devices connecting in from? Right? The notion of location is very important when you think about this notion of security. And finally, time. Right? The notion of time is equally important, right? Which is, if I have a contractor, an auditor, who's in for 3 weeks to do audit at the end of the quarter, after those 3 weeks, 5 weeks out, if I'm suddenly detecting access from that particular auditor, something's wrong, right? So the notion of time is equally important in this envelope of security. Now, if I have a set of rich primitives that I can use to get information from the network for all of this, then all these 4 bubbles really change to who is allowed on the network, what are they allowed to do on the network, where are they allowed to come in from, right? And when are they allowed to access the network? And that becomes very easy to do once you have these primitives. And so the notion of policy, I think, in networking is going to start getting a big a boost when you start looking at how do we go build on-demand networks. Think about, a healthcare patient who's at home, right? And they're providing home-based services to that patient, and you need to build an on-demand network to access the records, and it has to be HIPAA compliant. Policy becomes very important. The notion of who's on that network becomes very important, right? So I think these primitives will start getting a big importance as you start looking down to the future. Talked about smart lighting. This is interesting, right? When I badge into my network, into the office building, if this is integrated into my network, I can immediately detect that this is an employee. He's coming in at the entrance of the building. Let me go power on the lights in his cube. Let me turn on the voice over IP phone. If he's not in his office, I can power down the voice over IP phone and save power over there, right? And as he walks into the building, the motion sensors in every light ballast can tell you exactly where the user is and light up the path. I don't have to walk into a floor and all the lights for the floor turn on, right? That's a waste of energy, right? Even more so, think about applications to customize this, right? When I sit on my desk and I program or I'm on my computer, I hate the glare that comes on my screen, right? It bothers my eyes, right? And I have 2 options today. I either turn off the light or I deal with the glare, right? But what if the user can provide customized capabilities, saying if it's an LED lighting system, I can adjust it, I can play with it, and I can save my profile of what lighting arrangements do I want, right? And the centralized management platform can go adjust that, right? So when I badge in, it turns the light on and automatically sets it to my preference, right? That would be pretty cool. Let's talk about the data center as another example, right? There's a lot of talk today around virtualization and efficient utilization, where today you can move virtual machines around. And in fact, there are tools that do that today, for example, based on CPU utilization or memory utilization. But what happens if you move the virtual machine to a portion of the network where the network is actually congested? Have you accomplished anything? Right? I mean, you really haven't done much from that perspective. What if in doing that, you've actually moved the virtual machine away from the data it needs, right? And you've broken data locality. What if you move the virtual machine away from another virtual machine that it needs to talk to, right? And you've broken VM affinity. So if you had the right set of APIs, you can actually build some pretty cool tools to do VM load balancing based on all these other factors that today people are not really taking into account. Now, there's another interesting example that falls out of this, right? If your network can give you the information of who's accessing the application, right? Where's the bulk of the access is coming from? You can use that information to actually create a CDN network without creating a CDN network, right? Because what you can do is, at a given time of day or over a certain period of time, if you detect that the bulk of usage for this particular application is coming from another geographic location, you can actually move the VM to that location. And in effect, you've created a CDN without building a CDN, right? So there's some pretty interesting things you can do over here if your network has the richness to go make that happen. Right? So these are a couple of examples just to stimulate some thought around where we can go once the network starts building in some of these rich primitives. I'll end with this slide. Networking is no longer a fat pipe, right? It's no longer plumbing. It's plumbing, it's fixtures, it's pressure control valves, it's your shower heads, it's all of that put together, right? And this networking disaggregation, I think, will happen over the next decade, and it will drive a discontinuity in the way people think about networking. Content-rich APIs will come about, and they will provide developers, it will provide all of us with a phenomenal opportunity to rapidly innovate and create some very interesting applications, not just in the traditional networking space, but in all these different areas where networking is now going into. It'll provide a tremendous benefit for the customer because it allows customers a lot of flexibility. It'll break the customer-vendor dependency cycle. It'll allow customers to deploy targeted solutions instead of vendor-driven upgrades. And so it's a big win for the customer community as well. And finally, I think fundamentally the world's going to move from a connected world to a networking world. And we think it's networked today, but there's so much of the world that's not networked, right? And I think that's going to start happening very quickly as well. So I'll end with that, and I'm open to any questions, any discussions that you'd like to have. Thank you.
We have time for a couple questions. I've got one for you, Shahzad. I mean, this disaggregation idea is really very powerful in terms of what it's going to permit people to do, but it's also adds complexity in the sense that I had a completely integrated thing I could think of as just one box. Now I have a lot of finer grained control over. So there's obviously some sort of balance there between capability and complexity. Have you given that any thought?
Yeah, it's a great question, actually, and it's a very valid question, right? Because it is a mindset shift, right? It's very easy today for a vendor to go to, for a customer to go to one vendor and get all his problems solved from that one vendor. So that's the good part of having a vertically integrated solution. And that's definitely going to be a challenge, right? Because the mindset shift is not just for us as developers or for the silicon vendors or for the OS vendors. The mindset shift is also for the customer, right? I'll give another challenge as an example. I got a network switch or a network application deployed, right? And I've downloaded, a solution that some developer has provided, and it doesn't work. Who's going to troubleshoot that, right? Who owns that? Is it the network switch vendor? Is it the, the OS vendor? Is it the application provider? How do I figure all that out, right? I think we can take a page from the computing era, right? Which is today, I've got a Windows desktop, I've got a Mac, right? The silicon's coming from somebody else, the OS is coming from Windows, and the applications are coming from Adobe, right? And I've managed to live with that. It's taken a while, right? It took a long time for folks who are used to the mainframe to make that transition. So I think that transition will take time. It will be a mindset shift, but it's one that will take many, many years to go. But I think ultimately, in the end, the flexibility and the benefits you gain out of it will far outweigh the challenges around dealing with the disaggregation.
So your architecture does promote a lot of proprietary control plane level pieces, vendor-specific pieces, and your argument about, well, you can get it to be more responsive kind of still depends, if the problem is from there at least out, kind of still depends on the vendor. Are you suggesting that market forces will improve that responsiveness and that market forces ultimately will lead to some kind of standardization of the boxes and protocols beyond that?
Yeah, I think that's a great question, right? So first of all, actually, it's not my architecture. It's a vision on how things may ultimately transform. But I do think you're right, is that as the industry evolves, right, as networking moves, for example, to smart lighting systems, right, as it moves into broadcast video, there will be two threads, I think, that will happen in parallel. There will be a standardization track. That will be the initial track. It will get you far enough that the industry can move forward with the adoption of it, right? And when that starts happening, the broader market is going to see an opportunity, and everybody's going to jump in it because there's money to be made. And when they start jumping into it, everybody will innovate in their own direction. And I think that's a positive thing, right? Because it'll unshackle innovation from that perspective. And that's okay, right? So I think there will be two things that happen. There will be a standardization track, and then there'll be a lot of innovation that will lead to some proprietary development, which may be okay, right? Because at the end of the day, that's what will drive the momentum forward.
Great. Let's thank Shahzad again.
Thank you.